P2, the real number line, and order. The real number line. So the real numbers can be represented as points on a line. The positive direction is toward the right and indicated by an arrow. The origin for a number line we choose really as an arbitrary reference point that corresponds with the real number 0. Given any convenient unit of measurement, each positive number x is represented by the point on the line a distance of x units to the right of the origin, and negative numbers are x units to the left of the origin. So if I were to pick the number 4, 4 should be 4 units to the right of 0, which is my origin. Negative 4 is 4 units to the left. Order on the number line. So the real numbers are ordered. A is less than B if B minus A is positive. A is less than or equal to B if we use that extra symbol. Okay. So A is greater than B if B minus A is negative. And again, that or equal to has that extra line underneath. On the real number line, what we want to do is graph all of the numbers that satisfy each inequality here. So we have that x is less than 3. So what I want to graph are all the numbers that are less than 3. So on my number line, I want to make sure that I mark off where the number 3 is. I like to just pick a number to the left and to the right of it. I feel like that's more than enough information. And we want to graph less than 3. So less than means we are not including 3, so we will use an open circle, but to the numbers that are smaller than 3. 2 is smaller, so we'll shade in that direction. Kind of hard to shade on this. Okay. In B, it says that x is greater than or equal to negative 2. So again, I want to see where negative 2 is on my number line. A number to the right would be negative 1. To the left would be negative 3. Remember, the negatives are kind of backwards. Greater than or equal to, which means negative 2 does satisfy this inequality. So we're going to shade that in. And we want numbers that are greater. Negative 1 is greater. So that would be the numbers to the right. X is greater than 1.5. Again, we want to see some numbers on this number line. So if you want to put the integers, you can, or if you want to put 1.5 here, a little bigger would be 2, a little smaller would be 1. Greater than, so we are not including it, but we want the numbers to the right. And then we see that 6 is greater than or equal to x. We can kind of flip that around though. So we have x and 6. If we notice, x is the smaller one in this case. So we want to make sure we're reflecting that. We need 6 on the number line, 5 to the left, 7 to the right, or equal to. So we're going to shade that in because 6 could be a solution here, and we want less than. If you notice, there's kind of a neat trick. As long as your variable is on the left-hand side, whatever way your inequality symbol points is the way your arrow will point, as long as x is on the left. Sets and intervals. A set is a collection of objects, and these objects are called elements of the set. If S is a set, the notation A is in S, that's what that weird looking E symbol is, means is in. A is in set S means that A is an element of S. When we put the slash in it, it means that it is not an element of it. So for example, Z is the capital letter we use to represent the integers. That's because whatever the word in German is for integers starts with the letter Z. Then negative 3 would be in Z because negative 3 is an integer, but pi would not be in Z. Some sets can be described by listing their elements within braces. So for instance, the set A below consists of all positive integers less than 7. So we have that A is equal to 1, 2, 3, 4, 5, 6. We could also write A in something called set builder notation. So set builder notation is where we say that A is equal to all of the x's such that, so this line here really means like such that x is an integer and x is between 0 and 7. So A is the set of all x in an integer, between 0 and 7. So union and intersection, when we're talking about sets, then we can talk about where are they kind of overlapping, okay? So if A and B are sets, then their union, A union B, we use this weird U looking shape, is the set that consists of all elements that are in A or B or in both of them. So we're including everything, all of A and all of B. The intersection of B, or of A and B, sorry, is the set, and we use an upside down U, consisting of all elements that are in both A and B. But really we're only talking for intersection about the overlap. So this is where they overlap. The union includes everything. And then we have something called the empty set, and that's that circle with a slash that you likely used for no solution. What that means is there are no numbers inside that set. So the empty set contains nothing. It contains no elements at all. All right, so in this example, we're going to find the unions and intersections of different sets here. So we're given three different sets, set S, T, and V. So the first thing we want to do is find the union of set S and T. So what we're going to do is include all of the numbers from S and T. We just don't want to repeat them. There's no need to write the same number more than once. So we would say that the union of S and T is equal to, and we'll use these curly braces. We see we have the numbers 1, 2, 3, 4, but 4 is repeated, 5, but 5 is repeated, 6, 7. So 1, 2, 3, we only need to write 4 one time. We only need to write 5 one time, 6, 7. So we're including everything. However, when we're doing the intersection, so this is S intersection T, we only want the numbers that they both have, that they have in common. So they only have 4 and 5 in common, so 4 and 5 are going to be the intersection. And then for S intersection V, let's see, S is 1, 2, 3, 4, 5, V is 6, 7, 8. There is no intersection at all, so that would be the empty set. Okay. Whoops. Certain sets of real numbers called intervals occur frequently in calculus, and they correspond geometrically to line segments. So for example, A is less than B. If A is less than B, then the open interval from A to B consists of all numbers between A and B and is denoted by the symbols. So I know it feels like it's a coordinate point, but that is not a coordinate point. What this is saying is that this parenthesis is not including A, and that parenthesis is not including B. We could also, though, instead of an interval notation, we could do set builder notation. Set builder notation is this right here. So this guy is interval notation. This one is set builder. You will be asked to, do one specifically or the other specifically, depending on the question. So when we say that we're going from A to B, we are not including A and B here when these are curved parentheses, okay? So this is saying that X is really between A and B. When we have a closed interval, we are including them. That would be that or equal to. So that's where we see these kind of squared off braces here, or brackets, okay? That's when it changes to or equal to. So if I wanted to say that we had, that we had 2 is less than or equal to X is less than 5, okay? The or equal to is going to get the squared off one. The just regular less than is going to get the curved one, and that would be 2, 5 on the inside. So you have to try to be as neat as you can to show the difference between the rounded one. Oh, I'm making that worse by making it bold. But the rounded one and the curved one. You really do want to make it clear that there's a difference. Also, we want to consider the fact that sometimes our interval can go off to infinity. So in this case, we use the infinity symbol, which is a sideways 8. If I wanted to say that X was just less than 5, we would have that curve in the 5, but we would go off to infinity in the other direction. To the left, we'd go off to negative infinity. If we were going off to the right, say we had that 2 was less than or equal to X, and that was it, we'd have the 2, but we'd go off to infinity in the positive direction. Infinity is always going to have a regular curved parenthesis. All right, so here's just some examples of what the graphs would look like. We have our notation. So this is our interval notation. This is set builder notation. And obviously the last ones are graphs on a number line, just so that you're clear which one is which type. Okay. So if you see, we use open circles when we are using that open parenthesis, and when we have that squared off bracket there, we are using a closed circle. When we go off to infinity, we are using either a line that just continues or an arrow. To express, what we're going to do is to express each interval in terms of inequalities, and then we are going to graph that interval as well on a number line. So just as an inequality, kind of putting it back the way it would look in Algebra 1. So when we see this squared off in A, that's going to be an or equal to. When we see the curved one, that's just going to be a regular symbol. I guess we can use X. There's no reason to use anything else. We're between -1 and 2. So this means we include -1, and this means that we do not include 2. So when we go to graph this, we will have a closed circle at -1 because we are including it, and an open circle at +2 because we are not. And we're talking about all the things in between. Same concept for this next one. Because they're both squared off, they're both or equal to. So we're between 1.5 and 4. So both of my circles now should be closed. A little hard to color in on here. I think I did an okay job. And everything in between. The next one, we see the curved parentheses. So that's just a regular less than. So we're between -3 and, well, infinity. We don't really write inequalities like this, though. So we would really just write this portion, and that's saying that x is greater than -3. Here's my -3. Open circle. If you want to put some more numbers, you certainly can. In this case, the other ones, we had enough information to be clear where we were. And we're greater than, so we're going off towards positive infinity. And lastly, we have that negative infinity. Again, we don't normally write this, but it might help to give some context. Is less than x. That boxed off is going to be or equal to. Really, again, we don't write that infinity portion, so we would just say that x is less than or equal to 2. It's understood that we're going off to the left forever. So here's 2. Less than or equal to is filled in. 3 and 1. And we are going to negative infinity, so that would be to the left.